Hello and welcome. This is the group project video for CPE 185. This is done by Dylan McNeely, Breeana Proffit, and Joesph Kassel. For our project, we decided to track exoplanets using the MAX32 and the Raspberry Pi. So to give a brief explanation of what exactly our project is trying to look at, an exoplanet is any planet that is outside of our own solar system. And how we were tracking these is through the 2001 Kepler project that was started by NASA. So what they did is they sent the Kepler telescope into space to focus on certain stars, and what they would be looking for is a dip in brightness. And the reason why they were looking for this is if a exoplanet was traveling around the side of the star that was facing us, there will be a slight dip in the brightness since that light is getting blocked by the exoplanet. So to confirm if this is an exoplanet, we would look for the same size dip 3 times, and basing on the assumption that the planet is the same volume when it rotates around the star, it will confirm if that is really just an exoplanet or if it's just a misreading in the data. So how we would accomplish this project is the user would first select a Kepler data file that he or she would like to be analyzed through the push buttons and an LCD display. This file name would then be sent to the Raspberry Pi using I2C connection for data analysis. The algorithm on the Pi would look for dips in brightness and send back any confirmed exoplanets. This result could then be viewed by the user on the LCD display. Unfortunately, our project is still yet incomplete. This is due to many problems we had with the I2C technology. Because of this, many of our individual parts are just left on individual circuit boards that may be different than the ones specified before. The way the LCD display is working at this point is that it is printing the star name on the first line of the LCD, and the scroll feature for the second line works with only one push button. This is running through an individual program with the Arduino, and it is all wired onto the same smart Uno board. The goal of the project was to have this wired to the MAX32, which would relay the analyzed information to the LCD display. But because it is not yet complete, it is only being tested individually right now on the Uno board. The data analysis algorithm works as followed. Essentially, the Kepler data file would have 2 axes based on brightness and time division. Our algorithm would look for the dips in data, and using line integrals would be able to tell the volume under a certain threshold, so it can be compared with other volumes to tell if it was a match for an exoplanet. After it was found to be a match, it would then transfer back over through I2C back to the MAX32 for display. Lastly, how the I2C communication would work is through the SCL, SDA, and ground pins on both the MAX32 and the Raspberry Pi. We attempted to send the data as a string split into chars, which are 1 byte each. We ran into a lot of problems with this technology and ended on having the data only appear as either a 16, a 0, or some weird looking squares. Looking back on this project, I wish we had more time to actually complete all the parts of the project. We ran into a lot of problems with the I2C technology, which basically put a huge roadblock in us finishing this project. If we could have had more time, if we got the I2C technology working, we would have been very, very close to finishing this project, and really would have just had to go through debugging to make sure everything is working right. Overall, even though this project wasn't exactly a success, I feel like me and my group mates learned a lot about all this kind of technology and ran into a lot of problems that we hopefully will have more experience with in the future. Thank you, and this concludes our video.